In this video, we're going to do another example of solving an exponential. And this one's actually really cool. I can solve this one both using a logarithm and not using a logarithm. So I'm going to try and split that up and show you both methods here. Either way, doesn't matter which method I'm using. Before I can do anything, I have to isolate my exponential, so my base and its exponent. So what that really means is I need to get rid of this 2. Well, the operation between the 2 and the 3 is multiplication, so I can just divide it to the other side. So now I have 3 to the 2x minus 1 equals 27. This is the step where we can do two separate things. So really interestingly, 27 can be rewritten as a base of 3. So I'm going to show you what that looks like on this side. So I could rewrite this as 3 to the 2x minus 1 is equal to 3 cubed. In that case, this one's super simple. We can just plug 2x minus 1 equal to 3 and then use our SADMEP to solve this out. So I'm going to add 1 to the other side. 3 plus 1 is 4. X is equal to 2. Nice and easy. But we can't always do this. Not always when we isolate the exponential will you end up with a number that can be rewritten as the same base. So I'm going to show you the other method that we could use here that would work even if this wasn't something we could rewrite with the same base. So in that method, we're going to take the log of both sides and we're going to use the base that is given to us. So we're going to say the log base 3 of 3 to the 2x minus 1 is equal to the log base 3 of 27. This side, the log and the 3 cancel out, leaving me 2x minus 1 is equal to the log base 3 of 27. We're going to assume, just to show you guys the full way out, that we don't actually know what this is. We're going to imagine that maybe it was like log base 3 of 29, something we couldn't evaluate. So if this was something we couldn't evaluate, we would still use SADMEP to isolate x. So the first thing I'm going to do is going to add 1 to the other side. And then I need to divide by 2. Now I'm dividing absolutely everything by 2. So that is going to give me x equals the log base 3 of 27 plus 1 all over 2. So oftentimes we will see answers that look like this when we're dealing with logarithms. Either it's because they just ask you to leave it in logarithmic form, or more often than not, it's because the logarithm we have can't be evaluated unless we have access to a calculator. And so we would leave our answer like this. Now, for this sake, we can actually show that we should get the same answer. We know that the log base 3 of 27 should be 3. I'm going to add 1, and then I'm going to divide by 2. 3 plus 1 is 4, divided by 2 is equal to 2. And notice we did get the same answer. But if it asked you to leave it in logarithmic form, this is what your final answer would look like. Now, if you've been watching a lot of my videos, you might be thinking, Miss Sample, don't we need to check our answers? And actually, we don't need to check our answer here because my original one does not have a logarithm in it. Because I do not have a logarithm, I don't need to double check that my argument is positive. So when we're dealing with logs and solving, we're only going back and checking if the original equation had a logarithm in it.